To talk about bonding forces or attraction, first I want to say there is intramolecular, which is within the molecule. They are very strong and they are broken into metallic, ionic, and covalent bonding, which are all electrostatic attraction. But you could also have a bonding among the molecules, and those are known as intermolecular forces. They're relatively weak, but they can be compared and they each have a different distinction. Hydrogen bonding being the strongest, then you have dipole-dipole for polar compounds, and finally you have something known as London dispersion, which is for non-polar entities. Now hydrogen bonding, the requirement is the hydrogen should be bonded to nitrogen or oxygen or fluorine. Why nitrogen, oxygen, or fluorine? Because they are very electronegative and very small. And that causes to form a polar bond which is very strong. So nitrogen to hydrogen, and then again oxygen attached to hydrogen in a compound, and then fluorine attached to hydrogen are very polar. Some example of those are, for example, ammonia. Ammonia has hydrogen bonding. Water, H2O, has hydrogen bonding, and hydrofluoric acid has hydrogen bonding. Now, this is extreme of dipole-dipole. Dipole-dipole by itself, which is weaker than hydrogen bonding, is when hydrogen is not attached to fluorine or oxygen or nitrogen. For example, if you have hydrochloric acid or hydrogen chloride, this is partially electronegative, partially electropositive, and this forms a polar compound. And when you put two of them together, they're going to have that stickiness. So if I put another hydrogen chloride, they're going to attach or hold on to each other, but not as strong as a hydrogen bonding. So this is dipole-dipole interaction or affinity or attraction or bonding. Finally, London dispersion is just for nonpolar entities. So for example, if I put a chlorine molecule, it's perfectly happy, but these electrons are going to move randomly and they might instantaneously get locked in one position, and they're going to induce a polarity into the neighboring molecule, and there will be a weak attraction known as London dispersion. Now we are going to look at it a little bit more carefully. So intermolecular forces applies for covalent compound for molecules. If you are polar, you can be categorized as either hydrogen bonding or simply dipole-dipole interaction. If you are nonpolar, on the other hand, you only have possibility of London dispersion or temporary dipole. So for example, if I give you H2O, H2O looks like this. So it's a bent molecule. And if I put another H2O next to it, it's going to line up like this. And if I put partial charges, this is negative, positive, positive, positive for hydrogens, negative for oxygen, and this here is going to be strongest dipole-dipole, which is known as hydrogen bonding. So here is the attraction among these two molecules. So this is H bonding. If I give you a molecule of ammonia, for example, ammonia looks like a pyramid. And if we put another ammonia in the vicinity, the nitrogen of the next door ammonia is going to attract the hydrogen to form a hydrogen bonding. So these hydrogens are slightly positive, positive electronegative. nitrogen is very negative and very small, very electronegative and small. And what happens is we are going to form a hydrogen bonding between this nitrogen and this hydrogen here. So the molecules stick to each other, their boiling point goes up. So relatively, hydrogen bonding is very strong. If I give you a molecule that doesn't have oxygen, nitrogen, or fluorine attached to hydrogen, for example, if I give you HCl, slightly electronegative, slightly electropositive, no hydrogen bonding, and if I put another molecule next to it, like molecule HCl, they are also going to attract to each other, but now this time it's going to be a weaker attraction. This is known as dipole-dipole attraction. So these two molecules are not going to hold on to each other as strong as two molecules that we had before as hydrogen bonding. So these two molecules are going to have a weaker intermolecular attraction. For London dispersion, then again, you should sort of imagine what happens is these nonpolar molecules, for example, if I give you Cl2, and if I give you two Cls attached to each other like this, they have equal electronegativity, so the bond between them is shared equally. Neither side is really negative or positive, but what happens is momentarily the electrons get locked in one side and make that side negative, the other side is positive, and if you have another like molecule next to it, there will be induction or polarization, and now this time becomes positive, negative. So if I put few of them together, they sort of hold on to each other like this, positive, negative. So imagine each of these oval shape is one molecule of Cl2, and now there is a tiny attraction among the positive and negative, the neighboring, and these are known as a London dispersion. London dispersion, which is a temporary dipole caused by movement of electrons.